All right, good afternoon, everyone. Thank you for joining in. How many of you all have already been doing iOS pen testing or any sort of pen testing? Okay, 1, 2, 3, hands raised, 4, okay. Uh, you guys know what pen testing is? Yes. Web pen testing, everyone is familiar, right? Okay. Mobile pen testing, Android, little bit. Okay, okay, okay. All right. Today's session we are going to see on macOS pen testing. That's a different type of pen testing. Okay. So we'll learn what exactly is macOS. Okay, how macOS exactly works. It would have been better if you guys would have been little bit familiar with mobile pen testing, specifically iOS, but that is fine. We'll also cover how iOS pen testing works. So I have curated this session in such a way that any level of beginner or any level of professional can learn from it. Okay. Uh, you can take these notes. Okay. For web application, you know there's a application called as damn vulnerable web application, right? It's a basic application we all might have used. If not, we might have also used port trigger labs, right? Those are like vulnerable labs. So what I've done is to make macOS things simpler. I've created an application called as damn vulnerable macOS application. I call it DVMA. We'll be taking insights from DVMA so that we are going to learn how things work. Okay. So a little about me. Who am I? My name is Vaibhav. You all guys might be knowing that I have 3 years of experience. Those are my certifications listed over there and some basic info which you can get online as well. Coming forward, okay, let me introduce you to the world of iOS pen testing. Okay, so iOS pen testing obviously means it's all going to be about iOS based applications, right? Do you guys know what is the extension for an for an Android application? It's an .apk. Okay, for an iOS application, .ipa. Right. Have you ever wondered what happens in that .ipa file? What all things are there in that .ipa file? Have you guys ever wondered about it? No, right? Let us see how it works. So developers, what they do is they have this source code, okay, and this source code is then compiled to a file called as .app. Okay, so you have a low-level source code. Your source code is compiled to .app. So just a Java. How many of you are familiar with Java? Java coding, very few. Python. Okay, okay, most of them. C, C++. Okay, so every one of us are some or the other way familiar, right, with coding at least. So when you compile a code, your source code gets run, right? But there's some procedure that happens over there. The source code gets converted or compiled to an intermediate language, which is then when you execute it, the operating system or your compiler or interpreter is going to interpret that and it's going to run that code. It's going to play around with your kernel functions and run that. Okay. Similarly, whenever you compile a source code, okay, it's going to get compiled to a .app file, which on zipping, okay, you literally zip it, is going to create your .ipa file. Okay, and this is not theory. Let's see a practical of it. Okay, so what I'm going to do is I'm going to do a reverse procedure of it. Okay, so we will be having the .ipa file. Okay, and from the .ipa file, okay, from the .ipa file, we are going to move to .app and we are going to see the source code of it. Okay, so for that, over here, I have something called as DVIA dot. Okay, just a moment. Yeah, over here I have a file called as dvia-v2.ipa. Well, DVIA stands for damn vulnerable iOS application. Okay, so it's a intentionally vulnerable iOS application that was created You can find its link on GitHub. Okay, but what we are going to do is we are going to create a copy of it. Okay, and we are going to literally change the extension to zip. Okay, so when I said that your .app file is basically a zipped version, I mean your .ipa file is basically a zipped version of .app, I am reversing that process. So from .ipa, I have put it to .zip. I am going to extract the zip contents, and this particular thing that you see over here is nothing but your .app file, okay, which is over here. This is your .app. How can you verify whether it's .app or not? It's pretty simple. What you can do is you can go over here, just write file and just put it over here, and you can see it says DVIA v2.app, right? So it's basically the .app file that we have over here. Now, once you click onto .app file, that is over here, right click and click on show package contents. Okay, you are going to see the source code of it. Okay, you are going to see the source code of it. Now the beauty of iOS based applications lies here. When an iOS based application is compiled, okay, its source code gets encrypted. Okay, so even if you decompile it and if you go over here and check for the source code, your source code is going to get encrypted. Okay, so you actually cannot find the source code. What can you find if not the source code? You can find strings out of it. Okay, so there's a command called as strings, and strings basically what it does is it's going to give you all the method names, method functions and everything. Okay, let's not go into much detail over there. Let's stop it over here. Okay, but all I wanted to prove the point is your source code gets compiled to .app, your app gets compiled to .ipa, okay, and your this .ipa file is then published to App Store. Okay, so on the App Store, when you search for, let's say, WhatsApp, okay, you get this .ipa file. Okay, on your App Store, you install it on your iPhone or iPad or whatever device you like, right? So once you install it on your iPhones, okay, there are certain functions that it's going to do. Okay, one, it's going to either connect with the local databases that is present on your iOS device. Okay, so on your iOS device, there are multiple databases that are present, right? So there is a database called as plist file. There's a database called as realm database. There's a database called as SQL database. Okay, there are multiple databases that are present. In web applications, we have databases like MySQL, right? We have MS SQL, we have NoSQL, right? Similarly, each iOS and each Android devices has its own database. Okay, we call it as the local database. So that's local database. We have something called as local files as well. So in Android, are you guys from that generation where we used to use Lucky Patcher? Has anyone heard about Lucky Patcher? Yes. Right, a lot of us. How many of y'all play Candy Crush or have played in lifetime Candy Crush? Right, most of us, right? You know, in Candy Crush, we used to use that Lucky Patcher application and used to manipulate to get unlimited lives in Candy Crush or unlimited lives in Subway Surfer, probably, right? So how do we used to do that? We used to modify or patch a binary file, and we used to or patch the internal file, and we used to increase the life to unlimited, or probably -1. -1 means unlimited. So Lucky Patcher used to do that for us. What Lucky Patcher was essentially, it used to increase the life to 99999, and it used to patch those files and then recreate or rebuild that application for you and then install it for you onto the device. That's what Lucky Patcher used to do us. Okay, so how? Because there are some internal files that are stored on the local file system of your device. Okay, so on your iOS or on your Android device, there would be some local files that would be saved. Okay, And then you have local authentication mechanisms such as your fingerprint, okay, your face ID, your touch ID. So let's say WhatsApp. So WhatsApp, if you open WhatsApp, there is an option wherein you can enable fingerprint, right? So without your fingerprint, you cannot enter into WhatsApp. So there's a local authentication mechanism. So your application that is installed on your iPhone will be using these methods: local database, local authentication, local files. Is it clear up till now, or am I confusing? Clear? Perfect. If you guys feel, please interrupt me at that point of time and I would be happy to solve your doubts. Okay. Now we talked about local methods, right? But an application does not rely on local methods. It needs to fetch data from server. Just like your websites needs to fetch data from server, similarly your application also needs to fetch data from the server. Okay. So there are multiple ways it can fetch. Okay. So those are fetched by how? By APIs. So it can fetch files from the web server probably, or from the file server, or it can fetch data from the database server. We don't know at the backend what is happening, right? There can be multiple database servers, there can be multiple file servers, right? So this is the basic iOS application structure that happens. Now, as a consultant, which all areas should you be focusing? Let's talk about that. Okay. So I usually like to split this into 3 parts. Okay. Now on the internet you might find it into 2 parts as well, which is also perfectly fine, but I usually call it as a 3-part process. One, I focus on the source code. Okay. That's where you will be doing your source code review or your source code analysis. Next, I try to focus on the local database, local files and local authentication methods. Probably that's the time wherein your local database, local files and local authentication is the point wherein you might find something sensitive, or you can bypass your local authentication methods as well. Okay. So that's what I call it as static analysis. On the internet you might find that source code review plus the part 2 is combined into one and is usually called as static analysis, which is fine, which is absolutely fine. You can call them a static analysis as well. But for simplicity, what I do is I usually call out these 2 separately, because your source code review is as important as your static analysis part. Okay. What do we cover in source code and what do we cover in static analysis is the question. In source code, we usually cover something like file permissions. Okay. So let's say there's a application, there's a calculator application. It should not ask for your photos, right? Or it should not ask for your call recordings, right? That's a very simple understanding. If it asks for it, that means it has something malicious. It has something malicious intent. So issues like this are usually found in the source code. So on the source code, you will be able to find that there are some issues like this. On the local database and local files, let's say you have your password and the application is storing the password in an unencrypted way. Now, if your device gets stolen, okay, I get your device, I can unlock it and I can go to that particular local file and I can find what is your account's password. So that way your password should not be stored. The likelihood, so there are 2 basic terminologies that I usually like to speak about. One is the impact. Storing your password on a local device unencrypted has a very, very high impact. Okay. But the likelihood of happening it, whether such situation will occur or not, is what we call as the likelihood of happening it. So the likelihood of happening it is very, very less. Okay. It's let's say 10% chance that your phone might be stolen and the password might be cracked and I can grab this particular data. There's a very less chance, right? But as pen testers, as consultants, what we usually want to do is we want to make our application so strong from all areas that we follow the principle of defense in depth. So defense in depth is a principle wherein you implement as many defenses as you can. That's why we call it as depth wise. Okay, so we put in as many defenses as we can. So that's the reason we also give this as a finding, probably a low finding, because the likelihood of exploitability is very less. However, the impact is high. So we can give this as a finding, as a low finding. So this is the two areas where I usually like to focus. Third area is your APIs area. Okay, so your mobile application can be considered as your web application essentially, okay, and all of those APIs that are going forward and backward, you can test on them, okay, just like you do your web application. So on web application, let's say there's a cart functionality, you add and you delete data in the carts, right? Similarly, in your mobile application, if there's a cart functionality, you can add and delete data in those carts as well. So that's the third part where we call it as dynamic analysis. Okay, so this is just the three test cases, understanding of it. Source code reviews, decompiling, reverse engineering and analyzing the code. Static analysis is static components of the application like databases, files, etc. And the third one is dynamic analysis, where we play with the requests. Okay, now playing with the requests might involve preliminary steps of SSL pinning bypass, which probably we'll be going to see in the next session by Tarak. He is going to explain about how various SSL pinning bypasses can happen. But yes, those are three preliminary test cases. Okay, let me skip this. Yeah. So our topic is macOS pen testing, right? It's not iOS pen testing. I just gave you a brief about iOS pen testing. Our primary focus is going to be macOS pen testing. How are we going to perform macOS pen testing in this case? Or essentially, basic or before that, what exactly is the macOS structure? Okay. So when I speak about macOS thick client applications, right? I have used the same image, right? Why? Because there are no major differences that happen at a structure level. Okay, at a structure level, there are no major differences that happen at the structure level. Everything is same. Your source code gets compiled to your .app file, which on getting zipped gets compiled to a .dmg file. On iOS, it was .ipa file. Over here, it is .dmg file, which then gets pushed to your app store, which then gets installed onto your macOS application. Okay, and it might have local databases, local files, or local authentication methods, right? And it might also communicate with various different APIs, either with the web server or database server. Okay, so your macOS application structure is exactly similar to your iOS application structure. Your iOS application structure is almost more or less similar to your Android. Now I'm not saying coding wise, I'm saying structural wise. Okay, in Android as well, there is a similar thing. You have a source code, it gets to a small e code, then it gets to an APK file that gets pushed to Play Store, and everything happens. So the testing structure remains the same. Okay, so you don't have to worry about it. All you need to remember is source code, APP file, and DMG file. In Android, this APP file will be replaced by a small e code, and it will be then compiled to an .apk file. That's the only thing. So if everything remains same, your analysis or your testing also remains same. So you have one, the source code review, second, the local database system, third, the web server and the database server. So your testing remains the same. What are the key differences then? There should be some difference, right? What are the key differences? The key differences lies in one, data storage part. In iOS applications, okay, you have something called as keychain, NS user defaults, core data, SQLite, etc. Over here in macOS application as well, you have keychain, plist, SQLite, core data. There are some binary protection mechanisms that have a key difference. That's in the key difference, but we are going to ignore that. There's something called as network security. Okay, network security also has some key differences. Let's ignore that as well. What I want you to remember is about the two parts, the static analysis and the dynamic analysis part. So in the static analysis, you can see we have IDA Pro, Hopper, GHydra, OTool, ClassDump, MobSF tools. Okay, MobSF is most common tool that we all might have heard of or might be using. In macOS, we have Hopper, GHydra, OTool, etc. Okay. Dynamic analysis tools, Frida, Cycrypt, Objection. How many of you all have heard about Frida? Very few. Okay, very good, very good. The rest of you all have completely not heard, or at least have some idea. Completely not heard? Okay, okay, okay. We'll come to Frida as well. Okay. macOS applications, again, it's similar. So what are we going to do is, right, before jumping into it, let me also tell you something about SIP. Okay. So what SIP is? SIP stands for System Integrity Protection. Basically, it's a feature in macOS, okay, that helps you reduce your threats to malware and exploits. Okay. So what SIP is basically going to do is, it's going to see whether an application that you installed is basically malware, has a malware or does not have a malware. Okay. So if it has a malware and SIP is enabled, it's automatically going to put that application into a sandbox environment. Do you know the term sandbox? Yes. What is a sandbox? Can anyone? Yeah.
Sandbox. हिंदी में चलेगा?
हाँ हाँ.
Virtual box. Sandbox.
Type of, but exactly?
Type of.
Virtual environment. So sandbox is basically an environment wherein it's away from your primary system and it can have a lot of, like, you can do whatever over here. So what SIP is going to do is, SIP is going to put your application into a sandbox environment if it finds that there is some malware into it. Now, we have a tool called as Frida, right? For those who do not know what Frida is a dynamic instrumentation toolkit, okay, which is going to help you bypass a lot of stuff, okay. So it's going to help you bypass root detection, jailbreak detection, SSL pinning. Now you might ask, root detection, jailbreak detection, ये सब क्या होता है, right? It's बड़े terms है, क्या होता है exactly? So in order, okay, how many of you all know what rooting is? 2-3 people. उसके अलावा रूट नहीं किया कभी डिवाइस को? बचपन में तो किया रहेगा ना सबने, रूट तो किया रहेगा, ठीक है. So for those who do not know what rooting is basically, in very simple terms, फ़ोन को ऐसे कुछ करना जिससे पूरा फ़ोन का OS बदल जाए, right? That's what we have done. Installing custom ROMs on a device, right? So we have been doing rooting to install custom ROMs on a device, right? So that's the basic thing that we all have been doing, rooting. But actual में मतलब क्या होता है rooting का? So yeah.
Basically to get admin level access.
Admin level access, right? So Linux तो सबने यूज़ किया है, उसमें sudo su लिखते हैं तो क्या होता है? root user बन जाते हैं, right? Ideally root user नहीं बनते, super user बन जाते हैं. su का मतलब होता है super user. So you become the super user, okay? So in Android, if you want to gain super user level rights or you want to gain the administrator level rights, you need to root that particular device. When you root that particular device, you get admin level rights. Now once you get admin level rights, you become a superhuman, okay? So you can interact with the kernel, you can do n number of stuffs you want to do with the kernel, you can manipulate the kernel, you can patch the kernel, you can do whatever you want, right? So what application does is, application checks whether you have super user rights or not, okay? And if you have super user rights, it's going to say, भाई तुम्हारा phone hack हो चुका है, हम तुम्हारे phone पे नहीं चलना चाहेंगे, okay? So that's what we call it as root detection, which means that if you have super user rights on your rooted Android device, okay, the application is going to stop working. The same thing implemented on iOS devices is called as jailbreak detection, okay. So if your iOS device is jailbroken is rooting ka equivalent for iOS, okay. So if your Android device is rooted, your iOS device is jailbroken. So if your iOS device is jailbroken, okay, the application is going to say hey, your iOS device is jailbroken, which means you are prone to attacks, which means that I cannot run on this particular iOS device. That is what we call as jailbreak detection. Okay. Now, the point comes over here is specifically in iOS, okay, if you want to view these local databases and local files, you can only view them if you have root access. Okay, so you can only view them if you have root access. So in order to view them, you will require jailbreak to jailbreak your iOS device. And as soon as you jailbreak your iOS device, your application is going to say, hey, I cannot work on jailbroken iPhones. So what we do is we try to bypass it. So we try to say, okay, you have a feature implemented, that is jailbreak detection. What I'm going to do is I'm going to bypass it. Let me try to bypass whether your jailbreak detection is being bypassed or not. Okay. Additionally, tools like Frida, tools like Objection, what they do is they help you to bypass it. Now, how is it getting bypassed? That should be your question कि भाई ऐसा क्या मैजिक हो रहा है कि bypass ही हो रहा है पूरा, मतलब डेवलपमेंट स्ट्रांग नहीं है तो ऐसा क्या मैजिक किया कि bypass हुआ? That should be your question, right? So what happens is, let's say the application, what application does is the application is going to make a system call. Okay, so the application is going to say to the kernel, hey, are you able to use any internal binaries? Internal binaries. So in Linux, do you know there's a folder called as sbin? Do you know that? Right? What does that folder do? System binaries, right? What are system binaries? Huh?
System binaries.
We know the full form, but system binaries hota kya hai exactly? Let's see. Okay, so we have something called as sbin, right? So what does this sbin have? Sbin has a lot of system binaries, right? What are these system binaries? So the commands that you write, for example, ls, right? For example, cd, for example, sha, okay? These commands, how do they originate? Have you guys thought, how do they originate? इसका कहीं ना कहीं कुछ ना कुछ तो लॉजिक रहेगा, right? कहाँ से आते हैं ये commands? So all of these commands are basically stored into two parts. Okay, one is bin, that is called as binaries, and one is called as sbin. So if you see inside bin folder, you have something called as ls. Okay, now if you cat this ls, okay, this is basically the entire code for ls. Okay, this is the code for ls. Basically, this is an executable format of ls. Okay, what it does is कि भाई आपने जब ls लिखा तो उस टाइम पे क्या कोड एग्जीक्यूट होना चाहिए एट द कर्नल लेवल, वो ये सारे फोल्डर में अवेलेबल है. सो देयर आर टू फोल्डर्स, वन इज बाइनरीज एंड वन इज सिस्टम बाइनरीज. सो बोथ ऑफ दीज फोल्डर्स हैव commands written over it, commands के codes into it, okay, which are in executable format. So if you execute it from here, you will be able to get, or you will be able to run those commands that you are running on any command prompt. Okay. Coming back to our original question, what does the operating system do to detect whether it is a rooted device or not? So your rooted device and your jailbroken device, okay, they can only run these system binaries if they have root access. Okay. If they don't have root access, they cannot run these system binaries, or they do not have access to it. So what it does is, your application is going to send a trigger point to an operating system, and it's going to say, hey operating system, do you have access to these binaries? Can you run these binaries? If the operating system says yes, it says that, hey, your device is rooted, okay, or your device has root detection. If it says no, it's going to say, okay, no बोला है मतलब नहीं होगा. अभी when your device is rooted, it's either going to say yes or it's either going to say no, right? It's going to be hard coded. So it's either going to say true or it's either going to say false. Okay. So what my FRIDA does is, FRIDA sits in between the application, the operating system and बीच में FRIDA है, ठीक है? तो operating system ने अगर बोला yes, your device is rooted, तो FRIDA उसको convert करके बोल देगा no, device rooted नहीं है. तो application को क्या लगेगा कि device rooted नहीं है. Operating system ने तो yes बोला, लेकिन FRIDA बीच में बैठा है. FRIDA said no, the device is not rooted. Okay. So that's how your FRIDA works. This is the magic that FRIDA does. This is how your root detection gets bypassed. Okay. In terms of macOS, we need to bypass SIP. So in order to run rooted or malicious applications like FRIDA, you need to disable SIP first. Okay. How can you check whether SIP is disabled or not? So you can run CSR util. Okay, there was a command. Yeah, CSR util status. Okay. So if you run this, you can see there's simply a term called as system integrity protection status is set to disabled. Okay. Now some applications may say your SIP is disabled, so we cannot run on this macOS. How are we going to bypass it? We are going to see in a couple of minutes. So that was about SIP. Okay. Now since we are talking about desktop applications, thick client applications, there is something called as OWASP Desktop App Security Top 10. Just like you have OWASP Web Security Top 10, similarly you have something called as OWASP Desktop Application Security Top 10. Okay, what does this Desktop Application Security Top 10 do? It's a list of all of the findings that has list of all of the findings that can be found on desktop applications. Okay. Now these include both your Windows as well as your macOS thick client applications as well as your your Linux thick client applications as well. Okay, so all three of them are listed over here. It's just for your reference over here. We are not going to go into very much detail. The reason I'll be telling you in a couple of minutes, but this is how the desktop top 10 looks like. Okay, so you can refer to this later on. Why macOS testing? Okay, so macOS testing right now is a very, very niche field. Okay, the reason being macOS applications in India specifically, or macOS in India specifically, are used by very less people. Okay, corporates में जाओगे, corporates में ज़्यादातर people are using Windows applications, right? macOS applications or macOS or MacBooks particularly are used by global people. Okay, so if you are in a company that has global clients, okay, over there you will find a lot of macOS related stuff that is happening. Okay, so that's one thing that I wanted to tell you guys. Second is shared code base with iOS. So many times, how many of you all know about Flutter? Okay, over here maximum people know, over here very less. React Native. Okay, so for those who do not know, what is Flutter? Flutter is basically an SDK, a software development toolkit. Okay, what it does is, अभी मान लो you are a big company, ठीक है, and you want your website, you want your Android application, you want your iOS application, you want your desktop application, just like WhatsApp. Let's say WhatsApp is a big company, उसका WhatsApp web भी है, that is their website. उनका WhatsApp for Android भी है, WhatsApp for iOS भी है, WhatsApp for desktop applications भी है, WhatsApp in MacBooks, WhatsApp in Windows, WhatsApp in Linux, ये सारे हैं, right? Will they be maintaining six different code bases? मतलब सोचो एक छोटा सा फीचर ऐड करना है, लेट्स से स्टार्ट मैसेज का, मैसेज को स्टार्ट करना है, ये फीचर है, ठीक है, तो उनको सोचो ना 6 अलग अलग कोड बेस में जाके हर बार लिखना पड़ेगा, राइट? आई मीन दैट्स हाउ इट शुड बी डन, राइट? इफ स्टार्ट मैसेज है तो स्टार्ट मैसेज एंड्रॉयड में भी लिखना है, iOS में भी सेम कोड लिखना है, इधर भी सेम कोड लिखना है, हर जगह सेम कोड लिखना है. So instead, what newer companies are doing is they have started something with a shared code base. Okay, what's a shared code base? You write code only once and it can go through all of the platforms. Okay, so for example, Flutter is a very good example of it. So in Flutter, if you write code only once, you can use the same code for your Android application, for your iOS application, your websites, your desktop applications, your Python applications, your Django applications, everywhere. So you can use the same code base for each and every application. That's how the world is developing. So if there is a shared code base, okay, so if you find a similar vulnerability in iOS application, there is a high chance or a high probability that you can find this similar finding in macOS application. Okay. Then we have something called as privilege escalation risks, okay, weak permissions, privilege escalation risks, insecure data, reverse engineering threats, etc. These are all normal issues why you should be doing. Sandboxing we already talked about, okay. So now let's jump into the practical part of it, okay. So we have something over here. So I have created an application that is called as DVMA, okay. This is DVMA. DVMA stands for Damn Vulnerable macOS Application. It's a small, sweet application to test your macOS skills. Now you may ask कि मेरे पास macOS ही नहीं है, तो मैं practice कहाँ करूँ ये application को, right? That should be your question. So what you can do is you can ideally purchase. How many of you are familiar with AWS? Okay. AWS has an EC2 instance, that is a virtual machine wherein you can get your macOS EC2 instance. It is at a very cheap rate. I guess it's for $20 per month or per day, something like that. You'll have to figure it out. But one, you can purchase an Amazon EC2 instance for macOS. That's where you can practice your skills. Second, the best way out is there are macOS ISO files available all over the internet. You just need to download them and import it in your VirtualBox or VMware. Okay. Uske andar you just need to install this application. How are you going to install this? Onto my GitHub link. So you just have to go to github.com/vlakhani28/dvma. Okay, I'll be sending you over this link. But onto my GitHub link. I just there's some issue with my internet. Yeah. Onto the GitHub link. Okay, you can find all of these details over here. All you need to do is you need to download this DMG file that is present over here. This .dmg file. Okay. Once you download it, you need to double click on this DMG file. It's going to show you something like this, and you just need to move it over here. That's it. That's the only thing you need to do. Once you do it, okay, onto your launchpad, you'll be able to see an application over here. I have not kept it on my launchpad, but once you open it, it is going to see something like this. You'll be able to see something like this. Over here, onto the right side panel, okay, there are list of different vulnerabilities that I have included. Okay, so starting with the static analysis all the way to dynamic analysis, you will be able to find a lot of list of different vulnerabilities that are included. Let's take the first one, that is excessive permissions granted. Okay, so what I have done is to make things simpler, I have written a description. So the first vulnerability says excessive permissions granted. This indicates that the application has been granted permissions that exceed what is necessary for its functionality. I've added an OWASP mapping. So the OWASP top 10 desktop applications that we saw a couple of minutes back, I've added a mapping to it. Okay, so if you see, this comes under DA6, that is security misconfiguration. And there's a hint to it. How can you verify whether this has excessive permissions granted or not? The hint is you need to check the info.plist file for more details. So remember that slide wherein I said everything is similar, right? So what you need to do is you need to right click to this. You need to click on show package contents, go to the contents, and you'll be able to see there's a info.plist file. And inside this info.plist file, it is going to say that this uses, this uses camera, this uses location, this uses photo library. Okay, so there are these many permissions that it is using. which are unnecessary permissions. And since they are unnecessary permissions, it means that they are excessive permissions. And since they are excessive permissions, it's an issue. Okay? Why? Because this macOS application does not ideally need to take in my camera. Okay? Since it is taking in my camera, which means that it is an issue over here. Okay? Similarly, we have something called as hard-coded API keys. Okay? I'm not going to go through all of the details. I'm going to go through only those ones that are familiar with the web applications so that it's easy for you to understand. But as and when you progress, please make sure that you go through all of them. These are literally the issues that are found on the production applications. Okay, so these are all from my experience, from how I have been able to found them. These are similar to those. So the one that we are going to see is, one is excessive permission granted, that's what we saw. Second is hard-coded API key. So if you write over here your weather, it's going to fetch something like this. Okay, it's going to fetch the weather for Mumbai and it's going to display over here. Now the point is that this particular fetching of weather is done using a third party application, which is using an API key. Okay, it's using a third party API key and it's going to fetch data from there. Our task is to find that particular vulnerable API key. Okay, so how are we going to find that is the question. So remember I said you, or I told you, that we need to perform the static analysis. Okay, so when you are onto your macOS, okay, if you click on show package contents, if you go to macOS, there's a executable file called as this. Okay, and if you do a strings onto this, okay, onto this executable file, just a moment. Oh, okay. Okay, wait. Let us do strings once again. Yeah, if you do strings over here, can't open file. Oh, maybe we are in the wrong path, that's the reason. Okay, just give me a moment. Yeah, if we do strings here, okay, we'll be able to find all of the strings that are available. Now, using this, you can add a regex pattern over here, something like this. Okay. Yeah, you can add a regex pattern over here, something like this, and you'll be able to get the API key that is being used. Now this regex pattern, I know that it is using this exact regex pattern. I've done it so that it is simpler to show you guys, but you need to do a lot of stuff. Okay, you need to, so in the strings you will have to open all of these strings and you need to manually verify them, whether there are any hard-coded API keys that are available or not. And you can use a regex pattern, something like this, wherein it's going to grep A to F 0 to 9 times for 32 characters. Okay, A to F 0 to 9 for 32 characters, it's going to grep and it's going to show. So this is a regex pattern that I have used, but you can probably manipulate this regex patterns and use it. Are things clear or am I messing it up? Are you guys able to understand, interpret it, right? Okay. So there's something called a SIP as well. So as I mentioned, that if the application checks whether your SIP is present or not, it's going to show something like this, wherein it's going to say that SIP is disabled, which we already have seen, right? That SIP is disabled. So now what we can do is we can use a simple Frida script, okay, to enable the SIP. How we are going to do that? So for Frida, for those who do not know how Frida works is, Frida basically has two things. One is the Frida server. This is the Frida server, which you can, which what you can do is you can enable it, and once you have your Frida server enabled, okay, you can write Frida-n DVMA -h is the host, that is 127.0.0.1, and then we have to give the script name, which in our case is going to be sip.js. Once you hit enter, okay, and now if you go to the application, see over here the SIP is disabled, okay. Now if I simply go to hard-coded API keys and I come back over here, it's going to say SIP is enabled, which means that we have bypassed that disabled thing to enabled. How did it do that? So you can see over here, original CSR util output, what was it? System integrity protection status is disabled. What we did was we simply modified it. We modified it to say, okay, system integrity protection status is enabled. Once this has been modified, the application thinks that, hey, this is enabled. So why not we just directly show that SIP has been enabled. So that's how you bypass SIP as well. Similarly, you have something called as Touch ID protection. Okay, so on your macOS devices as well, there's something called as Touch ID. So if you click on authenticate with Touch ID, it's going to say, okay, now if I enter my PIN code or my Touch ID, it's saying authentication successful. If I click on the cancel button, it says authentication failed, authentication cancelled, right? We are going to bypass this. How? We are going to we are going to say cancel and it's going to get bypassed, okay? So let's try to do that. So again, we will be using a simple script, which in our case should be touch ID bypass.js, okay? Now if you click over here and if you click on the cancel button, it's going to say authentication successful. How did it do that? Again, it used a similar technique, okay? The OS is going to say, hey, Touch ID was cancelled by the user. Frida is going to modify it and say, okay, Touch ID has been enabled, or Touch ID message is success, and it's going to show it to the application. So again, it's a similar process. Next, let us see something called as an SQL injection attack, okay? So over here, if you enter any username, let's say admin, you're able to see admin users database, okay? If you enter, let's say user, you're able to see users database, okay? Our task is to perform an SQL injection attack, okay? So over here, I have made it very simple. If you write or 1 equals to 1, can you even tell me what this query does? Any idea? Anyone? How many of you all know about SQL injection? Okay, okay. Yeah, ये तो simple query है. हाँ? Password को comment कर देता है, right? So what does this query do? Does is it's going to comment the password. Okay. Now in SQLite, okay, since this is using SQLite at the backend, in SQLite there's a small thing. Okay. Before the comments, you will have to end that query. So if you execute this, okay, it's going to run. But if you can also end this query and it's going to dump all of the database that is available over here. So SQL injection attacks are also possible using macOS thick client applications. Then you have something called as command injection attacks. Would anyone like to try this out? So if I write ID command over here, it's going to give me an output. If I write who am I over here, it's basically reflecting the output. Can anyone try to execute this command? Command injection over here. It's similar to a Portugal lab.
Anyone?
It's actually pretty simple. Yeah? Semicolon and you tell me what command. Sorry? Who am I? Okay. Yeah. That's how it is executed.
So one second. What's your name? Who just said the right answer? Manthan. So Manthan, you will get a code from me. So after this, you can take it from me. Manthan. Okay.
Perfect. Okay, so that's how things happen. Now, a lot of times, something called as web views are also used. Anyone knows about web views? Android developers in the house? Yeah?
So, it's basically when you want to open an internal web page type thing, many applications use that.
Right. So, कई बार ऐसा भी होता है कि आपका जो एप्लीकेशन है that wants to load a website. Okay. So, loading a website from outside internet is done using something called as web views. Okay. But many a times application developers forget to enable or disable JavaScript. Now JavaScript से कौन सा attack याद आता है? XSS, right? So XSS attacks can also be possible in your macOS applications if web views are enabled. So for example, I'm going to go over here. This is going to load a application. Okay, it's basically Google app blog post application. And if you enter your query over here, a simple basic query, okay, and if you click on search, you can see JavaScript alert was executed, but it wasn't executed on the web application. It was executed where? On the desktop application. So this alert box is of the desktop app, not of the web view. Okay, so like this, you can implement or you can perform XSS attacks as well. There are a few more attacks, okay, but we won't be going into detail of those, taking the interest of the time. So what you can do is you can view all of these attack scenarios, and you can try to perform all of them. Okay, where's my presentation? Yep. Okay, so what we did essentially was we performed, okay, we performed a source code review and a static analysis of the application. We performed a dynamic analysis of the application like bypassing SIP, web view attacks, SQL injection, command injection attacks. There are a few more attack scenarios which you can try at your own end. And this is about damn vulnerable macOS application. The website for the same is listed down over here. You can have a look at there. And yeah, that's it. Thank you very much. If you guys have any questions, you can ask me.